Hello, everyone. We're about to start our, not our, but my session of Docker. Thank you for coming in. I see that there's not too much people here around. That's understandable because this is the longest session here. It is like 90 minutes, so you will really need the strength to go through all of this. I have 100 slides, and I'm 100% ready for your questions and everything else. I will try to make a Docker presentation. That means that I will try to cover Docker as a technical thing, first and foremost. And after that, a colleague from Zagreb, Dalibor, he will make a session about using a particular Docker solution for the Drupal that is called Docker for Drupal. So let us start. First of all, thank for Drupal Hard Camp in Zagreb. Thank you for hospitality. Not hostility, hospitality, I know what I said. And so far it is really great to be here. We will start with the theory of everything. I hope that you have maybe heard for the theory of everything. It is very interesting theory. Unfortunately, Albert Einstein tried, after he declared his relativity theory and both general and special theory of relativity, he devoted 30 years of his life in trying to find the theory of everything. Actually, that is what it's called like. So he tried to find the formula that will bind the gravitational and electromagnetic forces into the one, just like he tried to connect energy with the mass and the speed of light. That work, unfortunately, wasn't fruitless for him, but some 30 years later, we are still working on the theory of strings. Later, when this presentation will be available online, you can check if you wish to see how his quest has gone on the site of Applied Physics. By the way, there's a film, The Theory of Everything, but it doesn't have nothing to do with Einstein himself, but the Stephen Hawking, whose black hole radiation was some kind of a starting work that could make something between the gravity and electroforce. Well, anyway, let's get back to Docker-driven Drupal development. First of all, that's me. I've passed actually the Acquia test. I was surprised myself. I would recommend you to try to do the same. It isn't very hard. I mean, if I could do it, probably you can too. I'm using computers and I'm in IT since 8th year of Unix epoch. I actually work on the terminal like this one. And yes, it was IBM terminal. Then I had some very interesting experience with Z8 assembly. I also done this. Does anyone recognize the blue screen? Yes, Commodore 64. Excellent machine, by the way. Then I was working really with this environment. So you see it's far from the GUI. And that's the chip, actually. And I was in C, and I really enjoyed that. That's the hard thing for the hardliners. Then I've got the fancy thing, like I got in Mac world, went into desktop publishing, and then I gave up all this crap and landed on Drupal 5. The guy yesterday said that he started with Drupal 4. Congratulations, I didn't. I was there from Drupal 5. Today, I'm trying to put my experience to the school of Coder, which will be available, unfortunately, only in Novi Sad for the beginning. That's like MVP. Does anyone know what actually the unique epoch is? Really? That's the measure of time. That is when you... What? 70. 71st January of the 1970 is known as the POSIX time on Unix epoch. Okay, the question is, what will happen on the January 19, 2038? You. The problem is that Unix time is measured as a 32-bit signed integer. So we will run out of time, and every computer that is based on the 32 bits will cease to function. It will happen the millennium bug, but in the Unix time. So we are pretty safe until that. If you're interested what time in the Unix epoch now is, this talk started actually 15 minutes later than 1,495,202,400 seconds. Okay, this is very inspiring quote from my really favorite guy, Steve Jobs. He gave that sentence on his commencement speech in Stanford on the June the 12th on 2005. Stay hungry, stay foolish. Stay hungry means that you should always strive for knowledge. There is no excuse not to learn all of our lives. And stay foolish usually means that we should be creative while not that kind of creative. Anyway, I would like now to hear from you to introduce yourself. So I'm just more familiar with who am I speaking to, because that will make it easier on me to decide on where to go deeper or less deep. So I will ask you a few questions, so you just raise your hands and that will be fine. About the operating systems that you're using, how many of you are using Linux as a basic? Okay, not too much, like 6, okay. How about Mac? Mac users are majority. I won't ask for the third one, I don't care about them. Joking. Who is on Windows? Oh, I pity you, really. Okay, about the experience, how many of you are like system admins or DevOps? Okay, few hardliners. Backenders? Majority. Okay, frontenders, you had the talk right there. How many of you are experienced about the networking, virtual private servers or VPSs? Okay, some here. Okay, if I embarrass myself during the talk, just please raise your hand and correct me if I'm telling something wrong. Here's one very famous developer. Actually, he's developing some flying objects, not too popular, but then again. This timetable is, of course, not accurate because I put 10 minutes on everything, and that would make 100 minutes, and we also already lost some of them, but we will try to make it up. So, let's see. What's the main problem that we are talking about here? What are we trying to solve? When we look at this picture, we see that we have a few operating systems. Some are really challenged, some are less challenged, and some are somehow natural to the web development process. And why is that so? Because we're using mostly Linux servers, and of course, if we are in Drupal world, rarely anyone uses the technology from some big and ugly company that I will not name now. How many problems do we actually have when we're talking about the development? So it's not the development, it's just the development. We have a series of problems, and I've just put some 9 major here that I see as a problem. Let's see. We have system setup. Everybody knows that system has to be set up for the web development. At one point in your life, you have the first time that you have to set it up. You make a hell of a lot of bad decisions about configuration, about will you use Apache or Nginx, will you use this or that, and it takes some time until you make everything right and make it operational. Usually, it's when you buy a new computer or you're upgrading your system. For instance, your hard disk failed, you have to install everything from the scratch, and you usually delay that decision, if you can, of course, because it is just hard to set everything up. These are some common reasons for needing to make a system setup. But you know, eventually it's a good thing to set the system from the scratch, because you're losing some things that you gave up, and you're cleaning the system a bit. So it's actually a good thing. Then you have the project setup. When you have the project setup for yourself, like self-case, we have to face the fact that we are actually having more than one project in our life. Usually, we are working on multiple projects at the same time. Every project that we are working on also has some particular requirements that we have to fulfill, and that is why we always have to set up a new domain, set up a new virtual host in our Aperture and Nginx. You're all familiar with that. Set up a new database. When you have to clean that up, you have to archive it. Then you have to think about how you've done it and everything else. So far, it's not too complicated. It becomes complicated with the second project and the third project when you say, I have to do that again and again and again. And here's the first thing that really starts to suck. That is quick fix. For instance, we had some project we were working on. We finished the project, released the project. We are happy, client is happy, everyone is happy. We are forgetting about the project and moving on to the next one. But then again, after a year or so, client says that his site is not working. Why the site is not working? Something has changed, and you have to have a quick fix. Probably most of you know that you have to bring back the project to the active state. So you have to set up again a local domain for the project. You have to set up virtual host. You have again to deal with the database, and you have again to clean everything after to release your machine from the unneeded data. No one wants to do that because sometimes there are differences between the time when you were originally developing and today, and that difference could be a problem. Then when a new colleague comes to the company, you again have to go through the same steps. So you were hating the steps the first time when you were doing it for yourself. Now you have to do it for the other guy. Okay, that's now really a bit boring, going through all the things again. Then his computer is different than yours. You figured out that Nginx is better than Apache, and he's still on Apache, and you're figuring, should I make him Nginx work? And when you do, you regret your decision because there are many things that has to be done, like PHP, FPM, and other things. And as you can see, these are bold, and bolder. And you're just beginning like your voice is trembling when you talk to the young colleague, but you still have to do that, so you do that. Then, like it's not enough, there are weird requests to the project, like old PHP 5.3. Some of the things that we're working on the 5.3 doesn't work at 5.6. You can find instructions how to have multiple PHP. It can actually run. I've made that run. But then you have to make different configurations. You have to include the PHP service in a different way. And then even if you're on the same web server, like Apache, there are differences between 2.2 and 2.4. You usually want to match the development with the local development. So that is why you really would like to make that work. So then you essentially rape your web server on your local machine, because you want to make it work, because you need that to work for a client, and you're really having hard time making Apache and Nginx coexist together. You have to stop the service and things, and you really don't like that, but that's the business, that's the thing that you do, and you have to do that. Then comes the project requirements, like someone would like Solaire, someone would like Elastic, someone would like different versions. You have, again, to do the thing that we don't like to mention. And then when you make all those changes, clients simply dump everything because they figured out something new. They will outsource it, and all your work and all your system changes are just simply gone. And my favorite, which I had myself, I don't really like that, especially when that happened, is that when I made the final commit and wanted to shut down machine because it was overheating and virtual memory was way above my head, and I just finished and wanted to shut down the machine as soon as possible. And then what happened? There came the upgrade. I started the upgrade. I didn't want to break it up. So, okay, never mind. Let it finish. And when it finished, of course, configuration changed because it upgraded the Apache from 2.2 to 2.4. And I have to recheck all my virtual hosts because they were simply not working anymore. As you said, fortunately, I'm not on strong pills, at least not anymore. And then comes the testing. For instance, will my site work under PHP 7? Or how about HHVM? Does anyone know what the HHVM is? 1, 2, 3, 4, 5. Wow. So you're really DevOps. Okay, kudos from that. And while you take care of your Zen garden, trying to stay sane, this is the final and ninth thing, that if you can have your code in Git, if you can have your configuration in Git, if you can even put your database into Git, how about having your server configuration also in the Git, which would be available for colleagues to Git clone from your repository, which would be available for DevOps, for deployment, and you may be asking yourself, is that possible? Yes, it is. You can use the virtualization. Virtualization would be an answer for the previously mentioned problems. Probably some of you have heard for the Vagrant. Vagrant, which was used with different virtualization providers, could make some things a little bit easier on us. So let's see what types of virtualizations do we have. We have full virtualization, hypervisor virtualization, and containers, which is, and I emphasize, not a virtualization for itself. Okay, let's see how that works. This is our usual or typical operating system, where we have our local machine, so it's basically the hardware. We have our main operating system, few of those who have Windows or Mac or Linux. We have system-wide binaries, libraries, services like web server, database server, and everything else. And then we have our applications like in this case, those are websites. So we have one website, other website, third website, fourth website. What actually do we have here? We have different projects that we are developing concurrently, and they have, as you can see, they have to share the common things. So in the beginning, while you're a young developer starting to work, that suits you fine, simply because you're in your Windows, you're using PHP Storm for Windows, you're using whatever for Windows, you have Photoshop for Windows, you have how it's called, Axure or something like that. So you have your applications, you have your environment, you're comfortable with that, and that looks fine. But still, while there are, while you have your machine, because they're sharing things, sometimes things are not as ideal as you would like them to be. So what are the drawbacks? Everything that is stated in the previous chapter about the problem. Every change on the system is very sensitive because it affects all the system. So if you change the PHP, you change for the all sites. While this seems easy to set up on one machine, you know, you have tutorials all over the net, how can you implement this or that. Still, you need knowledge. So it's never easy to set up a PHP FPM or web server. Nothing comes easy out of the box. You have to know what you're doing, actually. What could be the benefit of one system without virtualization? It may look easy way to start or for undemanding development. So if you're looking like 2 or 3 WordPress sites, that would work fine for you. Okay, 2 or 3 Drupal sites, it will work fine for you. And the overhead in such system is next to none. So there is no overhead. As you can see, we have only 3 layers before our applications. So applications are theoretically at least as fast as possible. Why they are not as fast as possible? Because they still have the operating system running on top of them. That's the difference why your local machine is sometimes slower actually than your server who has worse hardware than you may have. Let's see how full virtualization architecture may look like. We have now infrastructure. So we're not calling it the machine. We're calling this the machine. This is our local machine. But when we're talking about the servers, it is always infrastructure because it just operates differently. And we may have different paradigm what the infrastructure actually is. It could be some balanced hardware that is behind some wall of our understanding. So we're not calling it machine anymore. We're calling it infrastructure. On that infrastructure, in order to have full virtualization, we usually have a host operating system, which is running in parallel with the virtual machine engine. For our applications that were native and were just used to their common and shared libraries and binaries, in our virtual engine, we have guest operating system that is running its own binaries and libraries for the application 4, and the other guest operating system that is running binaries and libraries for our application number 3. What is the benefit of all of this? Well, we can see that our host operating system is completely separated from the guests. So whatever happens in Las Vegas, stay in Las Vegas. So our guest operating system is the system for itself. For instance, what if it catches a virus? I mean, it will not happen in Linux, but whatever. What if we mess something here up? No big deal. We remove our application, build a new virtual machine, and continue where we. Why it's good? It didn't affect our host operating system. Our PHP storm still works. We don't have to reinstall the Windows or Mac or anything else. So this does make sense for us. Of course, full virtualization, which is almost as a physical machine, runs hardware that is virtualized and accessible to all virtual machines. And they also make available all hardware resources with the drivers so that application is actually not aware that it's running inside the virtual machine. So application think that it is running on a native system with the whole resources for itself. What are the drawbacks? maybe I should put the benefits before the drawbacks, but let's first see the drawbacks. The major drawback is that it runs in the same privilege ring as a host kernel, which could be a potential security issue. However, that is not crucial for us. For us, the crucial is that our operating system does not have the control of the virtual machine because they're equal, they're on the same level. So, but still we control the virtual machine, so it makes it okay, but it doesn't make okay the balancing of the resources. So if the virtual machines take a bigger cut from the system, that's what happens, and we cannot argue about that. Comparing to the other virtualization systems, full virtualization uses the most resources. So the full virtualization takes the biggest hit on your own machine. What is the benefit? Well, for the Docker, for instance, Docker requires Windows 10 or requires Mac OS Captain. So if you happen to have all the hardware or all the Windows system, then you have to go full virtualization. These are the common full virtualization providers. This is VMware. This is Oracle, which is free, and Parallels is also commercial virtual machine provider. Let's see now hypervisor architecture. In case you haven't heard for hypervisor, that is what the Windows recently acquired. It actually got a hypervisor in Windows 8, but that was something like partial, and from the Windows 10 it is a full-fledged client. It's the same with the Mac. Prior to OS 10.11 Captain, there could be virtualization, but it wasn't integrated well. And from the Captain now on, we have the hypervisor. When we're using the hypervisor, then we have infrastructure, we have host operating system, we have hypervisor, and we have guest operating system. Each guest operating system may have its own binaries, its own libraries, and its own application. So we are approaching to the idea that we are separating our web applications. Hypervisor is the most efficient way to run different operating systems, but usually limits the ability of virtual machines. For instance, we're usually not running when we're using hypervisor, we usually don't want to run it with a graphical user interface or something like that, but we're using the bare machine just as such. The main drawback with the hypervisor virtualization is that it has some performance hit, but much lesser than a full virtualization, and uses some resources for the guest kernel. So the thing is that hypervisor on the host kernel controls which provides cleaner relationship to the host resources. That means that hypervisor is able to run different operating system. Not different like CentOS and Ubuntu, but different like completely different, like running Windows under the Linux or running Linux under the Windows. That is the thing that hypervisor can provide you. The benefit, comparing to the previous system, is that it is lighter than the full virtualization and offers the flexibility just like the full virtualization, and usually provides the guaranteed resources like the CPU or memory. That thing is really, really important when you're buying your virtual private servers from the hosting providers. That is why you want to make the difference between KVM, which some people think it's a keyboard, video, mouse, but no, it's not. Does anyone know what the KVM stands for? You said you're DevOps. Kernel Virtual Machine. So those virtual machines based on the KVM actually are able to use different kernel than its own. Where do we need that? For instance, if we use the host machine as FreeBSD and we want to run it on top of it, to run Ubuntu, then the hypervisor is the only way. So that is why hosting providers which use KVM can provide you with the ability to use your own operating system like Debian or CentOS or whatever. So whenever hosting provider tells you that you can install whatever flavor of Unix you wish, then it's definitely KVM. Beehive is the same technology for the FreeBSD. When we are talking about the hypervisor types, we have, for instance, two types like type 1 and type 2. Type 1, on top of the hardware, is the hypervisor. That is like, you know, system, no? VMware ASICS system is this kind of a thing. And this kind of a thing is when you use your regular operating system and put a hypervisor and then guest operating system. So this brings us to the third type of virtualization, which is actually not virtualization. This is containerization. Containers use the special mechanism in the Linux kernel, which enables us to limit resources for some use. For instance, we can limit CPU usage, we can limit memory usage, network input-output, disk input-output. So we can control all the resources and assign each container its cut of the whole system, of the machine. Let's see. Containers are the most efficient way to run isolated applications in the host or cloud, the best possible way. So we have drawback here. There is some learning curve, but then again, everything does, really. And the benefits are, it is the lightest control mechanism with less than 5% overhead. I learned that some people on the previous demonstrations asked me how much does it cost to have containers. So it's about or less than 5% of the overhead. Resources like CPU memory can have granular control. So by default, they are just using the pool of resources and they are sharing it equally. So if you have one CPU, they will share it third for 3, fourth for 4, and so on. But you can assign one container to have more resources than the others. Here, resources are best utilized as they stretch dynamically. So that means that once one container is down, that means that that resource is free and everyone can claim it. I mean other containers. That is why they just, I mean, that is because when they stretch like that dynamically, they're actually very efficient in resource usage, because nothing is like in kernel virtualized machines. We usually hard code, this machine has these resources, and that's that. And that is when you're buying hosting solutions, that is why you want KVM. So KVM is like you're given something and the system guarantees to you that you will get your share. Even if your machine is not running, those resources are reserved for you. With containers, that can be done, but usually is not done, because we wish, when it's our machine and our control environment, we wish all the resources to be shared dynamically. And the main thing is, actually, that containers are very easy and fast to spin up, shut down, stop, restart, everything. Literally, it comes up or down in a split of a second. But let's not confuse the speed of the container with the speed of application. So if I start up MySQL database, the container will spin spin in a second. But that doesn't mean that the DB as such will spin in a second. It will spin in its own regular time. So, which are the container providers? Anyone knows this symbol? That is the maybe, no, it's not the oldest. I think that this one is the oldest, but this is LXC, the short for Linux containers. This technology was called Virtuoso. Has anyone used the Virtuoso as a virtual private server? No. It was very popular 4 or 5 years ago because it was the cheapest way of hosting. This technology brought hosting to $10, $15 a machine a month, but at the same time, the flexibility was misused for the hosting providers, which actually oversold resources. And that is why this was never recommended hosting technology, but still people like that because it's cheaper. Jails is the same technology for the FreeBSD. This is Linux vServer. It's maybe the oldest technology of all of them, although Linux always had some type of containers, but they were not actually called containers. And there is the most popular of them all. It's the Docker. Everybody heard about the Docker. And today, even Docker itself is spinning different types of containers, but that's a different story. So this chapter should be the longest one and the most important because it talks about the Docker. After that, we will have a few chapters where I will just breeze through because there are actually technology overview and to tell everything that would require like few days and that's just too much. So let's see how it's complicated to install Docker on Windows. Super easy. You just go to the Docker site, choose the Docker for Windows, choose the download, you get the MSI file, you start it, it installs. Of course, it's Windows, so you have to restart the machine. After you restart the machine, that's it. It just works. Or is it? Being the Windows, of course, it does not. I'm kidding, it works. But you have few things to do. First thing, you need to have Hypervisor enabled. You don't have to think about that. Docker will ask you, like, you need Hypervisor. You said, okay, and it will go and make it happen. If you have only 4 gigabytes, you will have to stretch the memory available to the Docker because it will not fit in. Windows itself uses about 1 gigabyte and something. And initially, Docker requires 2 gigabytes. So if you try to run Docker with Windows, it just doesn't start. It has a problem. You could see that because when you restart the machine, Docker will be starting, and then it will fail. If you have 8 gigabytes, it will be fine. It's not comfort to work with, but it's fine. Why it's not comfort to work with? Because that's not the only thing you need. So you need your PHP Storm, read 1 gigabyte. You need your browser, read 2-3 gigabytes. You need your something else. So 8 gigabytes would be hardly enough. But if you have 16 gigabytes, I'm sure you will be fine. Today memory is a bit more expensive, but we're in this business, so we have to do that. For older Windows system, we have to use Docker Toolbox, which uses VirtualBox, VMware, Parallels, whichever provider is. And after this, so when we manage to make this work, then we have Docker as any other platform. When we look at the Docker for Mac, the situation is even simpler than the previous one. You just go to the Docker for Mac, download. It's not the store; it's just it's just the name, the Docker store. So you just download the file, pick the Docker icon, put it to application, start it, starting, okay. You don't have to fix anything. The story is that you need Mac OS 10.11 El Capitan with newer processor from Intel. It should be from 2010 or newer. 4 gigabytes, just as in Windows, doesn't give us much. 8 gigabytes does gives us something, and 16 would be also recommended. That's from personal experience, I'm sure about these numbers. And just the same as with Windows, if our processor is older, then we have to use VirtualBox to make that work. On the Linux, there is, first of all, DrEngine is natively supported on Linux. So it is very fine. But on the Linux, there are some instructions on the site. How can you do it? But those instructions are lengthy, and you have to follow it. Like do this, do that, change these configurations, change that configurations. But this is much more easier. So you can use vget or surl to get this script. So when you make the fetch from this address, you got the script. You start that script in a shell, and it does everything for you. You will just see downloading, starting, configuring, downloading, and in the end, it will say, okay. I mean, it should say, okay. And when it stops, you just type Docker version, and it will claim something like 17.3 point something, which will be the current version. After that, Docker is treated like any other service on your Linux. So it's like the web server or MySQL. It is the service. You need administrative rights to start and stop like any other service or daemon. So you have usual commands like status, stop, start, restart, and something else. Linux usually don't have any requirement, except that I've seen from experience that we need kernel 4.4 or newer. That is the case with Ubuntu. So Ubuntu works better than the Debian, but it's not too hard for the Debian to change the kernel to the backports version. I've done that. It's not the problem. But the problem is that backports contains the 4.10 kernel, which is newer than 4.8, where we have this union file system which is deprecated, and this one is used, so it should be changed in a configuration. And we have something like, this is a warning, that we have to make processes and users in containers. They belong to the container. So container behaves like a different operating system. It's not, but it behaves like. And because of that, container has its own processes and own users, and owner and user are identified by number, not by name. So if you have like www data user which runs web server in your system, that is, for instance, on the Debian, it is user ID 82 or something, or no, it's 33. And if you use container, for instance, Alpine container, which is very light one, then it's 82. Don't get confused in the Linux world with the names. Names are just given to the numbers. So it is not important if the name is the same in both container and the system. The point is in the number. And that sometimes confuses the people. The second thing is that container is a daemon, and all daemons are run as a root. And if you want to control the Docker from your terminal, you have to be the same user in the same group as the root. So Docker daemon runs as user root and group Docker. So you have to add yourself to the Docker group, and then you will not need sudo for any kind of the command. So from this point now on, we should all be in the same boat. Or should we? It's like that joke, I know it's politically incorrect, but I don't care. Like in Southern Africa, in times of apartheid, there were a quarrel between black people and white people, and the driver of the bus said, "Stop, everyone out." So what? Everyone out. And when everyone got out, he said, "I don't care if someone is black or someone is white. You're all green to me, right?" And they scared said, "Okay, right. So get now back in the bus." And when everybody got into the bus, he said, "Okay, now light green goes in front, dark green goes on the back." Unfortunately, the same thing is here. We should be the same, but we're not the same because Windows and Macintosh don't have the Linux kernel, and they must have the hypervisor that allows them to use Linux kernel. And that hypervisor is actually full virtual machine. That is why on the Linux, networking and the storage works different from the Mac and the Windows. And Mac and Windows have some performance issues there. So Mac file system is HFS, Windows is NTFS, and Linux is usually ext4. So Docker in all systems use the same union file system to overlay or integrate local files with the changes in the Docker file system. Does anyone know what the union file system is? Okay, does anyone know what the mount in the Linux is? Right, so the thing that you could know that mounting a device on a Linux system usually goes to some path, okay? So you have usually /mnt, like mount, /something. So you give some path name, then you say mount this device to this path name, and that's it. Union file system actually unites the existing directory structure with the changes. So when you're mounting with mount command, you actually put the whole device into one directory. But what if you want to keep something from that directory and add the things that are on the device? That is what the union file system is. So the union file system in the Docker system enables us to add files on the current file system, where it would be useful as well. Try to think, for instance, you have CD. CD is read-only, we know that. So the thing is, we made a CD with some presentation and want to add some files to the CD. We can do two things. First thing is copy everything from the CD to our hard drive, add files that we need, make a new image, and burn it on the CD, right? And that is how the Windows or Mac users would do that without thinking. For Linux people, the thing is different. Linux people would use the union file system, and they will mount union file system with a CD. So it will be overlaid. That means the new files will be overlaid over the files that are actually on the CD, and then they would say, burn this content to some other device or make ISO file. That is how union file system works. So the union file system actually makes the union from the read-only device and the other device. And it will later become apparent why do we need that. Let's see some terms from the Docker vocabulary. Here we have the Docker machine, the Docker toolbox, Docker engine, Docker cloud, Docker swarm, Docker, Docker compose, Docker registry, and the Docker store. Some of these terms changed in the meantime. I mean, from the last year, for instance, but most of them stayed the same. I will now try just briefly to say about this, what are they and what are they used for. Docker machine. Docker machine was previously, that was the term that was used mostly by the Docker toolbox. So Docker toolbox was used to spin up a virtual machine, and when it spins the virtual machine, we used Docker machine command to control that machine inside. Beside that, Docker machine can actually control other machines. For instance, I'm running 3 servers, like bare metal servers. You know what the bare metal is? So bare metal, when you say server is bare metal, that means that it's not virtualized. It's the metal, it's the machine itself. So we use the Docker machine to control multiple machines with their configurations, their resources, their containers, and everything else. So briefly, Docker machine is the mechanism that we actually use to build cloud. That is the beginning of the cloud thing. What is the cloud thing? That is the thing that we are spreading our infrastructure between different data centers, different continents, different time zones, countries, whatever. And they all behave like one monolith system. That's the crucial thing. Docker engine is actually the Docker daemon. So the Docker engine is running on one particular machine and is providing the Docker services to the client. Docker Cloud and Docker Swarm. Docker Swarm was previously a different command that was controlling the containers on one or more machines. And Docker Cloud is the mechanism that Docker offers to us so we can use their controller, which is web-based, to control our infrastructure. Docker itself is the command line utility. It's written in Go language and inherits some syntax from the Go language. Docker Compose is something like, so we can spin one container with the Docker command, but we can spin multiple containers with Docker Compose. And that's the main idea with the Docker Compose. Docker registry is actually the main registry that is operating Docker images. And Docker Store is the same thing as Docker registry, but actually Docker Store offers reliable sources for the Docker images. Let's see briefly how Docker works. So when you install the Docker, which we've done in the previous steps, we can now start a Docker container. This is one typical way to start a Docker container. So what are we doing here? If you have some experience with the command line tool, then it's pretty obvious. This backslash is used to split the line into multiple rows just because it's easier this way to read. So I'm going to read you line by line what is happening here. So we are starting the command docker and say to the docker, please run the following container as a daemon, that means in the background, expose on the local port like 8080, and the internal port is 80. Give that container the name of Apache. Link that container to the provider MySQL and the container MySQL. Use the volume which will be on my native system in this path, and inside container it will be this path. This is the user from the Docker registry that I want you to pull the local container with the version of Apache. So after this command, we will have actually two containers running from the same line. First container is this. This is our container that we actually started. And just because this container needs the database, the Docker will also get the database and start it over. So we will have two containers that are running, and we can check if everything is working with Docker process status and Docker inspect. And here is the Go thing. Docker inspect filter. From the JSON that you get host config links, which is from the Apache container. And that's the name, Apache here. When we use this command, we actually have the container running. That container is apparently Apache web server, and it is available at the port localhost semicolon 8080, and it's working. So it seems like it's very easy. When you go to the hub docker.com, you have official repositories. That means that Nginx or Redis or BusyBox or Ubuntu or Alpine, these containers are provided by the authors themselves. So that is not like I made Nginx or something. No, it is Nginx which provided Nginx image for us. Of course, there are other solutions that we will see later. Here are some usual Docker commands. Docker controls individual containers based on the name and based on the ID. It's the same. You can give the ID or you can give the name. It will work the same. Here are most usual commands where you want to list all processes controlled by the Docker. All includes both running and stopped containers. This one is I want you, Docker, to inspect this container given by name. And when you want to check how much resources is Docker using, then you use this command, Docker stats, like statistics, and you say no stream. If you say just Docker stats, then it will update all the time, and you can see the resources usage in real time. Docker Compose could be described the best as a way to start multiple containers, and they will be grouped like an application or application stack. And this is taken from the official Drupal. So when you go to Docker official Drupal, you will get this recommended file. It is very strange for me that Postgres is recommended as database. Here is Drupal 8.3. It is exposed on this port. And as you can see, this looks pretty much like this one. Really, looks just the same. But the difference is that this is like a recipe that is contained in this file. So whenever you use this file, it will spin up exactly the same environment. And that is what we were talking about, the possibility to archive our server configuration. That's the way to do it. Here are some of the common Docker Compose commands. So you use Docker Compose to spin up, I will say, stack, because this will spin up more than one container. It will spin up in the background. You can pull latest version of containers. You can use this command to stop, start, or restart the container. And you can do the Docker Compose down. I will tell you now what is the difference between start and up. Docker images are actually, let's call them original. So when you use Docker pull, it pulls the image, and image is stored on the library of Docker images. When you say Docker compose up or Docker up, it takes a copy of the image, and that copy, we call it instance. So we use the instance of the original image, and that instance is actually our container. So Docker image by itself is not working at all. The instance is working. When we say up, that process makes the instance and starts the container. The difference is between starting and running. When we stop the container, we purge it from the memory. It stays on disk, but that is just like you press the pause button on your virtual private machine. So it's not in the memory, it's not working, it's not responding, but it is there. And as soon as you say start, it actually is coming from the disk into the memory again, and it is active again. When you say Docker compose down, it stops the containers in the memory, and when they are stopped, it destroys them. And that's a very important thing to remember. It destroys them. So they don't exist on the disk and don't exist in the memory. And when you make next command like Docker compose up, that will be completely new machine. Does anyone has the experience with Amazon services? It is the same like you don't use when you don't use persistent storage with Amazon. So if you don't use persistent storage and you shut down it's not container, but let's say it is. So when you shut down the Amazon instance, it loses all the data. So you have to have persistent data. But we will come to that later. Let's see now one thing. How are those Docker images built? So there is no mystery about that. There are recipes. How are they built? And those recipes are called Dockerfile. I will just briefly tell you how it works. So this says, from the base image that is made by Ubuntu, which is version 14.04, please get that container, start that container, and in the container, run apt-get update. After that command, run apt-get install yes Apache, apt-get install yes PHP 5 with following libraries, copy from my local file system this configuration into this path in the container, open the port 80 of the container for the outside world, and start this application with these arguments. So you see, this looks like you bought a virtual private server, you decided to use Ubuntu, and ran these commands. And actually, if you do this on DigitalOcean instance, you will get this service, even with this very same commands. So this recipe is actually used to build a working server like this. So this gives you even more control than the previous Docker Compose file. So this Docker Compose is just telling us how the image is run, and this tells us how the image is built. So, for instance, you wish to use Apache, but you wish to use not PHP 5, you wish to use Thin and Ruby. You say, okay. So, you take the same Docker image file, and instead of installing PHP, you install Thin proxy and you install Ruby. And that is your recipe. So you put this Docker file on your folder. You issue the command docker build with appropriate things. It builds the image that is held on your hard disk, and it is available for you. If you send those two files, Docker file and Docker Compose, to your colleague who is in New York, he just needs to say Docker Compose up. Docker Compose will build the image from this recipe, and guess what? Your colleague will have exactly the same environment as you're having while working. And that's the thing. We're using two text files to describe the whole server and the working environment. And that is what is awesome about the Docker. When we look at these terms, as we're running a bit out of the time, and I could use a lot of time to talk about only these concepts, I will go over them just briefly. So, Docker image is made by using this file. When I previously said that Docker is using union file system, here is how it works. We use Ubuntu as an image. With this image, we overlay this command, then we overlay this command. So when you say Docker pull image, you will see that Docker is downloading a few parts of the image. Those parts are in the Docker called layers, because those layers are just laid one on top of the others, so you get the file system that is actually this Docker image. So that is how Docker image works. Docker storage works the same way, but works for the storage, works for your data. Docker storage can be made by making the separate container that only contains your data, which is good and good for performance. And you can also bind the local directory into the container. So you can pass for instance, Drupal installation, you can pass inside the Nginx, so Nginx can serve your, so you're working in your file system, actually, and the Nginx is, it's like the window, you know, like the symlink in the terminal. So you're working on your file system with your files, and at the same time, Nginx see the same path. For instance, I'm working in /users/Mladen/sites/supershop, and that supershop/webroot, for instance, and the same path is in the Nginx visible as /var/www/html, and is served from that. So that is how the Docker storage works. If you mount the local path to the container, then it is persistent storage. Because when you destroy the container, your path stays alive because it's in your disk. It is in your Git, and it's controlled. And when you spin up the new Docker will also bind to that path, and it will just continue to work the way it was before. Docker networking is a bitch. And when I say that, I'm sorry to maybe some group of the people, but it's really a bitch. So I spent countless hours trying to figure out why some things are not working. I will try to describe what that Docker networking is very briefly. So when you spin up application, those containers that are spin up at the same time are in the same network range. When you spin up the next application, it is in a different network range. This network cannot see this network. So that is what the isolation is all about. They're completely separated. And only things that are explicitly exposed and connected through the bridge networking that is visible by both applications. Why do we need that? Because we need to, for instance, proxy our websites. So we spin up one group as one application, another group as another application, another group as a third application, and all three networks are connected through the bridge network that is used as a web proxy, which enables us to see them in our local browser as local names, as resolver. You will see that in a next presentation. And the last thing, but absolutely the most important, is Docker scale. Unfortunately, we're not going to do any live demoing here, but Docker scaling is, have you ever done the website that is served for the multiple servers? Something like load balancing, anyone? You know that load balancing doesn't work by itself. You have to make the configuration work as loading balanced, and sometimes you need to make application aware that it is balanced. Sometimes it could be database that is multiplied, sometimes it's the web server that is multiplied. That depends on the use case. With Docker scale, we are able to use one service and to make it multiple. How it works? For instance, I spin up Drupal site as application which have Nginx container, database container, PHP container, and that's enough. Those three. So Nginx, database, PHP. I will load balance database on a 2 master-slave replication. I will use 4 web servers as entry points for the clients. And I will use just one PHP because it's not much of a work for them. In a Docker environment, you just spin one service that is 3 containers, and then you know you have the smashing news, like Mladen challenged Djokovic to tennis match, and we all know I broke my leg, so I don't have a chance. But still, I want to fight him. That news is awesome, and everybody wants to read about that. And your site is experiencing a big hit on the web service. So what do you do in Docker? You say like this: Docker scale equals 10 Nginx. Done. And it replicated your Nginx in 10 more copies, and if you have load balancer, it's immediately working, and they're taking hits. So that is just like you, in one line, you spin up whole bunch of servers in no time. That's the main thing that Docker actually was invented for. And there is one small company that offers service, like search service. Company is called Google. They're a bit successful with their business model. They're actually operating not tens of thousands, but probably millions containers that are at the same time serving all the people all around the world. So it's very, very powerful. And it is really beyond the scope of this, but you can later ask me. I will gladly show you how it actually works. So I managed to shut off the thing, which is, aha, here it is. If we were live, I would try to show some practice live, but we're not. So let's see from this point, and we're losing time. So I will now burst through these slides. You will be able to see the whole presentation will be available online. So far, we have understood what the Docker is. We have some knowledge about how Docker works, And we have some basic Docker commands, and our service is running on our computer. What else do we need? We need something that we can spin our development process. So, okay, this was like theory, like you were going to the university and they were talking about you about the type languages and anything else, but they didn't teach you how to code. This is how you code. So we need that. We needed a solution. One of the solutions is, for instance, VodB Docker for Drupal. This is excellent thing. I'm actually using, and the next presentation, the guy will show you how it's used. I will just now stroll through the different options. All of the slides are clickable. So when you download the PDF, they all have the link to their source. So that is why I will just briefly go over that. This is another project. I must say, I prefer this one. And this one is where I based my work. But then I recently discovered this initiative. And this initiative is made by a very big company that is Friends from Work. This one is pretty complicated, and maybe it's not too developer friendly. This project is needed if you wish to connect all your containers and to be accessible by their name. This is better solution to do that, and that is also used in a Docker for Drupal. And this thing is sponsored by a company, Srce Interactive, and I actually have done it. That is my framework for starting a Drupal project. This is the first version. Just before this camp, I made a second version, which is much, much better, and will be available online very soon. It also has a link in the presentation. And let's see some myths. Some people think that it works right out of the box. Well, it does. But still, it's not easy. It's not like Photoshop, you click and it opens the picture, you click and it removes the background, you click and your eyes are from red turned to blue, and so on. That doesn't work. You have to know what you're doing. You can do it easily. Yes, you can. I mean, if you know object-oriented PHP, give me a break. You can do this. And this is easy, and you've got your reasons why it's a good thing for you. Not for me, but for you. And then we say, so no one can do this easily. Wow. This is, by the way, a large Hadron Collider in the Switzerland. And the size of a man is like about this. It's amazing how big it is. It's not impossible. And while you work, you will get into the problems. But still, the benefits are much, much bigger. The main question is, if you're working on infrastructure, then it's hard, but you probably have the knowledge, so it's not so hard for you. Or if you're using it locally on your machine, I think that this project, MCI Drupal, will get you up fast and running. There is documentation here which explains many things. I mean, people paid, I made it, and it's free for you. So you're free to go there and read whatever you need. I thought I heard something. Okay, so this is the almost final chapter, orchestration. What are the containers? Container is a service. It doesn't say what kind of a service, it's service. So the problem with the service is it just the Nginx? Is it just the database? Or it's Nginx and PHP and database is outside? That question is actually very easy to answer. The thing is, the container is what you think it's a single service. So if you put the database into the Nginx container, that's okay. It will work. But then you will not have the flexibility to scale them differently. And that's the thing with the scaling. So one container is one service that could be scaled. Services are grouped as application stacks. So one application for us is one site. And then those stacks can be load balanced, could be scaled, could be health checked, could be managed over infrastructure. And that is what orchestration is. This is the usual services that orchestration provides to the containers. And this is how you can check the health and the operation of the containers. This is for real. This is real life thing. This is what are the pre-packed application stacks. You can see here one application. And what is this? For instance, you want to run GitLab on your own server. You're working for the CIA, and the CIA doesn't want it to be available online. Okay, they put it on their server, and you give them the GitLab. But you have to practice. Will you buy a whole web server? No. No, you will spin a Docker. When you spin this Docker, you just choose here which is the latest version. You choose here to give the name, and you choose here how to configure it. Once you click the launch, it will start, and you will have the Git completely. You don't install Ruby, you don't check the configuration, you don't follow that 25 steps installation procedure where everything can go wrong. It's just done for you. You get the whole GitLab in just one click. And when it spins, you can check the health, you can scale it, you can do whatever you want. That is what the orchestration is. What the orchestration is not, it is not load balancing. So orchestration will not give you solution. Orchestration will just manage the infrastructure for you. And here are other options. The things that you saw is a Rancher orchestration. I've used that myself. This is the Docker orchestration. It's originally from the Docker. It's a paid service. Kubernetes, that is for that small company called Google. They actually decided to open source it, so it's open sourced. Mesos is a really open source project. I mean, that one is also open source, but this is under Apache Foundation. Rancher is free, just in a matter like GitLab is free. So you can use it. They give you the source. You can use it on your own server. And if you want paid support, okay, they will give you paid support. That is their business model. It is very easy to install. Unlike Kubernetes, Kubernetes require Ubuntu and require a head like this. Mine was not, I didn't succeed. And here are some services that are offered as infrastructure as a service. Heroku was the first one. It's not the Docker service. It is their own system. But if any one of you worked with Heroku, it's the same idea like Amazon Elastic Container 2 container service. This is the paid service, of course. You can get free account for 1 year, but it's a very tricky one. However, you can use it and feel how it's working. This is another hosted service that is different from the Amazon. Amazon gives you something, and Vodby actually gives you particular stacks. Drupal 6, Drupal 7, Drupal 8, WordPress, or something. And they can even, you can use their software to manage their own hosting, your own hosting, or somewhere else. It is very interesting company and the service. And here is the latest. You know, for the company Amazi, definitely. They're Swiss, they're very nice people. Michael is working on their infrastructure, and he's a very nice guy. You can meet him on most of the Drupal camps. And That would be all, folks. I approached 1 hour and 25 minutes. So in case you have some question, here's the Docker future. I think the Docker future is bright. It works fine. There is still a lot to learn, but it works. It spins fine. You can use Git repository to get everything right. I hope that some will find the workflow that uses Git repository where you can establish the webhook for merge requests and then to spin up the service. Those are just ideas for the DevOps who don't have anything smarter to do. And when you deploy that, that should be very easy, and then you should have your cup of coffee, tea, or game of darts. Resources are, of course, Docker documentation, which is original, and they're all over the net, but you really have to know what you're reading, or you will be losing your time, and that would be it. So right now, we will check the online questions, if there is. Will you please? And while we see if there were some online questions, I hope that I see that some are sleeping like this guy, but never mind. So if you have survived, I congratulate you, really. We don't have any questions online, so I'm open for your questions. If you have any, I can prove that I really know things. You trust me? Okay.
So about load balancing Docker, when you say that you can easily create multiple instances,
okay,
and they are out of the box working together, when you scale the Docker, is it really out of the box? Is it really working like that?
Yes. It is just the one line. Docker scale equals number and the name of the container which you want to scale. That's it.
Without any additional settings and any additional things?
No.
Okay.
It is like you have the server and you said, clone this one. And it just multiplies. So each machine gets its own network ID, but they're all the same. And they're working the same. For instance, I made a very, very small application the only thing that it's doing is return. So it's in PHP. It's one line. So I use just PHP like hello from, and then I use echo server IP and closed. And that's all I've done. That was my web application. And I just used that container and just said scale 5. And anytime you press the reload, it returns you the different IP address. And I guarantee you it's that easy. I mean, I can show you. The craziest thing to do is that, but listen, it's not working by itself. It's the traffic that load balance it. So the Docker will multiply the container at no cost. But you still need, as I said, you need your load balancer. So there is no magic Docker load balancer because it would be wrong. They left the balancer for you. And the traffic is the kind of the balancer that you can very easily use, and it's simply amazing. I mean, I will show you later how amazing it is and how easily it really works.
Sounds great.
Yes, and the thing is, we will post this PDF so you can download it, and you can really click on any picture. It will be a web link, so you can actually use all the resources, like no, not this funny one, but the things like when we come to the practical things like this or this, you will get the direct links. And the most important thing that I've done, or I hope that's the most important thing, is this. And here you will be able to find documentation on the Docker, on the principles, how it's working, and this will be used as a scaffolding. You know what that is? So it's like the template you just copy, you change the crucial references, like domain name and type of if it is PHP 5 or PHP 7, if it's Drupal 7, Drupal 8, you just change few things, say Docker Compose up, and it works. So that will be the main idea with this, and you will be in a position to download it freely. But I only need to return from the Drupal camp and finish that and push it to the repository. Okay, some other questions? Thank you for your time, for your patience.